All right, we had just graphed, we were adding 5 points to each of these data sets. I was feeling generous. These are test scores, quiz scores, and I added 5 to each score. So now each of these has been bumped up, and what you should notice about the plot there should be one up at 55 too. Okay, so now this is our new dot plot. It should look very similar, exactly the same shape. Okay, so what did we do here? We added 5. We added 5 to each x. Okay, so that's what we did. And now we recalculate the summary statistics. So I'm going to do stat, calc, one variable stats, but remember I put my list in list 2 this time because I took these and added 5, and then I'm going to calculate the one variable stats. So this time the mean is 45.4 repeating, and the standard deviation is 6.11, and the min is 35, Q1 is 40.5, the median is 45, Q3 is 50, and the maximum is 55. Alright, so if we just want to compare these values that we have, and what we want to do, I want you to be aware of this. What happens, okay, which ones changed? Okay, which summary statistics changed? So we're going to put a C by changed. Okay, so this one changed. Did the standard deviation change? Actually, no, it didn't. I just rounded differently. So this one stayed the same, S for the same. The minimum changed. Everything, all of these, every one of these changed. So the only thing that did not change was the standard deviation. Does it make sense that the standard deviation did not change? Okay, all we did was add 5 to every single value. We did the same thing to every single piece of data. The shape is exactly the same. The mean of 45 right about here, the balancing point, where the balancing point here was a little above 40, okay, it's the same thing, we're just shifting everything up 5. Notice, how did everything change? How did the mean change? We added 5 to it. How did all of these other values change? We added 5 to each of them. Okay, now a couple of things that we haven't yet found. The IQR, so let's now find the IQR for up here. The IQR is 45 minus 35.5, or 9.5. So the IQR for our first group of data is 9.5. The range is 50 minus 30, or 20. So now let's find the IQR here. The IQR is 50 minus 40.5. It is still 9.5. And the range is 55 minus 35, or 20. What happened to the IQR in the range? Absolutely nothing. These two remained the same. Okay? So the standard deviation, the IQR, and the range all stayed the same. They are all measures of spread. Because if you think about it, we didn't spread the data out more. We moved everything up the same amount. All right. So now we need to move on and look at some other, well, what if I did this? Now we go back to the original data. We assume the quiz was out of 50 points. And now we're going to change them into percents. So now what I'm going to do is multiply those by 2. So I have in my calculator, stat, edit, in my first column I have all of those test scores. I'm going to go to list 3 now, and up in the heading I'm going to take list 1 and I'm going to multiply it by 2. So now what I'm doing is I'm multiplying everything by 2. multiply all x's by 2. And now I want to see what happens to the summary statistics. First of all, I'm going to make my dot plot. My new data is 60, 70, 72, 80, 80, 86, 90, 90, and 100. All right, so does the shape look the same as the other ones? Well, yeah, I think it really does look the same as the other ones. Let's see if I have another graph around here somewhere. No, I don't think I do. Oh, I've got this graph from. Okay, does that shape look pretty similar? Okay, the shape looks similar, but what do you notice about it? Well, I notice it seems more spread out. The range used to be from 30 to 50, now it's from 60 to 100. Okay, so I do notice something about the range. So we could even write down the range. We know that has changed. The range is 40 now, and so that has changed. All right, we can find all the other summary statistics now by just taking and stat calc. And this time we have to tell it list 3, so second and above 3 is list 3. Calculate, and now all of my summary statistics, the mean of this data is 80.8 repeating. The standard deviation of this data is 12.21, n is still 9. The minimum is 60, 71 is Q1, the median is 80, Q3 is 90, the maximum is 100. So the IQR then would be 90 minus 71, or 19. All right, so now if we want to compare this to our original IQR, range, median, okay, so now we want to compare this to our original data and say what has changed. Okay, so the mean has obviously changed. How did it change? It multiplied by 2. The standard deviation has changed. It multiplied by 2 as well. Okay, the minimum, all right, the minimum used to be, let's see, it's on the other side of this paper. The minimum used to be 30. Okay, the minimum used to be 30 and now it's 60. So this multiplied by 2, not by 20. So that's changed. Everything has changed. Everything is twice what it used to be. Everything is twice what we already found it. So everything has been multiplied by 2. Now what about the range? The range was 20. Okay, that's doubled. The IQR has doubled. It used to be 9.5, now it's 19. Everything has doubled. All right, so which changed? Well, pretty much everything changed. The shape didn't change, it just became more spread out. All right, so now we've got some example problems here. A Manhattan taxi cab company studied the lengths of taxi rides and computed the following statistics in miles. The mean is 4.8. Remember, this is the length of a taxi ride. So the mean length of a taxi ride is 4.8 miles. The standard deviation, it ranges 4.2 miles above and below that. The median is 3.6. Q1 is 1.8. Q3 is 5.9. IQR is 4.1. If we converted the mileage measurements to kilometers, what will the summary statistics be in kilometers? In other words, 1 mile equals 1.62 kilometers. Okay, so when you do the reading for this, which is very, very important, it talks about how things change. And basically what you need to get from what we did up here is that every time you add a number to all values in a data set, and then we also need to think about when we multiply a number. by all values in a data set, what happens to the data, what changes and what doesn't. So we should, using that information, not have to know what all the data was. We should know that, okay, what are we doing when we do a conversion? Are we adding numbers or multiplying numbers, and what changes? So let's just review. When I added numbers, the only thing that stayed the same was the standard deviation, the IQR, and range. Everything else went up by that same amount. Okay, so the standard deviation, the IQR, the range, the main measures of the spread stay the same. Every other value of the summary statistics increases by whatever amount you added. Okay, if I multiply, or this even goes by dividing by a value, every single thing in the data set gets multiplied by that number or divided by that number. Okay, everything got multiplied by 2 here, every single value. So we need to figure out in a conversion, if I want to change miles to kilometers, we know that there is 1 mile per 1 mile equals 1.62 kilometers. Okay, so if I wanted, let's see, if I had 1 mile and let's see, how many miles in a kilometer, kilometers in a mile, what do we want to do? Do we want to multiply? Do we want to divide by 1.62? So in other words, a mile is longer than a kilometer, okay? So what we're going to do every time we have a mile, we're going to basically multiply by 1.62. So we're going to take the number of miles and we're going to multiply by 1.62. So if I converted every piece of data, which I don't have and I don't need, from miles to kilometers, all I would be doing is multiplying everything by 1.62. Here's how that's going to change all the data. I would be multiplying every data value by 1.62. So I would take 4.8 times 1.62 to get the new mean. The standard deviation would be 4.2 times 1.62. The median would be 3.6 times 1.62. Means you see what I'm doing there? All we would do is take everything times 1.62. Okay, you could make it really easy on yourself and just enter all that, stat, edit. I'm going to clear my first list. I'm just going to enter everything in my first list, and I'm just going to enter those numbers: 4.8, 4.2, 3.6, 1.8, 5.9, 4.1, and those are really the only ones where, whoops. Somehow I got back on the main screen. Okay, so then if I wanted to multiply them all, I could go to the heading of the second list and take everything in list 1 times 1.62. And then it would give me all of those new values. 7.76, 8.04. So this would be all of the values, all of the new values, if I change everything into kilometers. The shape of the graph would be the same. Okay, I'm just multiplying every value would be multiplied by that. All right, so now a taxi ride, if the cost of a taxi ride is $2.50 plus $3.20 per mile, what are the summary statistics for the distribution? All right, so here's what I'm going to need to do. I've got my mean of 4.8, my standard deviation of 4.2, my median of 3.6, Q1 of 1.8, Q3 of 5.9, and IQR of 4.1. First thing I'm going to do is charge $2.50 up front. So it's like I'm taking the average length, okay, and basically this is the length of a taxi cab ride. So to figure out how much I pay, what I'm going to do is I'm going to have to multiply all of these by 320. Okay, so let's do that first. First, I'm going to multiply all of these by $3.20 because for every average mile you go, I'm going to charge $3.20.